In this lesson, we're going to use the properties of parallelograms that we learned in the previous lesson to prove that a quadrilateral is a parallelogram. So our objective is to determine whether a quadrilateral is a parallelogram or not. The first theorem that we have says that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So here we can see that opposite sides are marked congruent in the diagram, so that quadrilateral is a parallelogram. The next theorem says that if an angle of a quadrilateral is supplementary to both of its consecutive angles, then that quadrilateral is a parallelogram. So here we have two consecutive angles that are 75 and 105, which are supplementary. They had to be 180. And the other pair of consecutive angles that are also the 75 and 105, both add to be 180 and are supplementary. So you have both of its consecutive angles. Both of the angles that are consecutive to the 105 are 75. And so that one is a quadrilateral. The next theorem says that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So in the diagram you can see the matching congruence markings on opposite angles indicates that that quadrilateral is a parallelogram. Next theorem says that if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So here it shows the diagonals of a parallelogram drawn. The congruence markings indicate that the diagonals are bisecting each other. The next theorem says that if one pair of opposite sides of a quadrilateral are both congruent and parallel, then the quadrilateral is a parallelogram. So here in this diagram we have the arrows that indicate that one pair of opposite sides is parallel, and there is a congruence marking on each of those as well to show that that one pair of opposite sides of that quadrilateral are both congruent and parallel. So that proves that it is a parallelogram. The note at the bottom says that you can also use the definition of a parallelogram to prove that a quadrilateral is a parallelogram by proving that both pairs of opposite sides are parallel, because that is just the basic definition of parallelogram. Is quadrilateral with both pairs of opposite sides are parallel. So you can use that to prove that's parallelogram as well. So let's look at the examples on the other side of the page. In problem 1, we're finding values for a parallelogram, and it asks for what value of x must quadrilateral RSTU be a parallelogram. So let's look and see what they have given us. They've given us, if we look at the opposite sides in this parallelogram, we have one pair of opposite sides that has 4y minus 3 on the left and 2y plus 5 on the right. And then the other set of opposite sides are the x plus 8 and the 5y. That would have to be congruent for it to be a parallelogram. So first use the left and the right sides because they both have y's in them. So we can set those equal to each other and solve for the y. Then substitute the y in to find the value of x. That would make it a parallelogram. So set 4y minus 3 equal to 2y plus 5. Solve that for y by subtracting 2y from both sides, and then add the 3 to both sides, and divide both sides by 2. So y is 4. So now we need to use the other two sides and set those equal to each other. Set the x plus 8 equal to 5y, and then substitute that value for y that we've just found, that y was 4. Substitute that into this equation for y. So we're going to get x plus 8 is equal to 5 times 4. So x plus 8 is equal to 20. And if you subtract 8 from both sides, then you're going to get x is equal to 12. So the answer for what value of x must RSTU be a parallelogram, the answer is x has to be 12. In problem 2, you have to determine is the quadrilateral a parallelogram with the given information. So can you prove the quadrilateral is a parallelogram? Based on the given information, what theorem can you use? So we need to apply the theorems that we've just gone over on the left side of the page. First one says that AE, the length of AE is equal to the length of CE, and they're both 14. So the length of segment AE is 14, length of segment CE is 14. Put that on the diagram. And it tells us that DB is 2 times DE. So if it's 2 times DE, that means that DE and EB have to be congruent to each other. So is it a parallelogram? Yes, it is. Why? What theorem would we use? Don't use the theorem numbers. You have to use the words for the theorem, because the diagonals of a parallelogram, I'm going to use the symbol for parallelogram instead of writing it out, bisect each other. So yes, it is a parallelogram. In the second part of the question B, you're given that the measure of angle Y is 49, the measure of angle Z is 131, and the measure of angle W is 49. Is quadrilateral WXYZ a parallelogram? So the question here, we're going to look at and see if we can apply the theorem that the consecutive pairs, if both consecutive pairs of angles, if both consecutive angles are supplementary, then it is a parallelogram. So let's look at this angle 131. So if I add 131 and 49, you get 180. And if you add it with the other consecutive angle, you're going to get 180. So they are both supplementary. So what theorem are we using? They are, yes, it is a parallelogram, because angle Z is supplementary to both. Of its consecutive angles. In the last problem, you're identifying parallelograms. It says a table tray can be adjusted up or down by raising or lowering the table on its hinged legs as shown. Will the table always remain parallel to the surface that it sits on? And explain why. So basically you just need to apply one of the theorems to indicate why this is a parallelogram or not. So it gives the lengths of opposite sides. The top is 10 and the bottom is 10, so those are congruent. And then the other sets of sides, left and the right sides are both 5. So we have opposite sides are congruent. So the answer to this is yes. Both pairs of opposite sides are congruent. So that means it's a parallelogram, and it will always remain parallel to the surface. So basically this lesson is just applying the properties of parallelograms to prove that a quadrilateral is a parallelogram or not.